So here comes the moment that probably everyone has been waiting for. When are we going to work on the ship? Now is the time. So we have our setup already going. Jump over and let's grab one of our pillars. Take that, duplicate that setup. Just hold down Alt and drag it. Wait for it to finish cooking. Let's just copy the name here. Get rid of that node here. And the most not complicated, but where we have to do the most adjustments in terms of the setup is going to be our ship. So what we want to do in this first part is set up our colliders correctly. So let's go to our pillars that we've been importing. And instead of our pillars, we're going to be grabbing our ship. So ship. Now let's see. Should be having that one in here. Perfect. And let's just call this get ship. Now probably can get rid of all this down here. Just quickly rename this to ship as well. And then also we have collider ship geo and then collider ship VDB. The rope is going to stay the same. The only thing that we do want to get rid of here is the deleting part, since we want all the ropes because they're all attached to the ship, as we can see here. So we do want the interaction of all of them. This will get a bit heavier, so I guess we're probably going to cache this just to save as much as we can. So pre-cache as much as we can. And so for the ship, we could just go ahead and do the same process that we did here. Let's just see why this unpack is failing. Yeah, because of the get pillars here. We can get rid of that as well. So down to the unpack. And then you already can see it's quite heavy. Getting slower and slower. Calculate the normals. That takes some time. And now trailing the velocity takes a lot of time. There we go. And then calculate the VDB, which is going to take even more time. And so to speed this all up, there's one easy thing that we can do. And I'll show you in a moment here. So we have this ship, which is basically moving around, just getting transformed, and that's it. Now, the only additional animation that we have that is not carrying on with the main is the guns coming out here, as you can see there. But other than that, the overall motion is the same for each piece here. So what we can do is utilize the intrinsics. So grabbing the transform attribute here. So if we look for packed full transform, for example, this is the animation that we have here, and you can see it's changing per frame. And so what we can do, we can extract this information, which is super quick to read, and then apply that to a static geometry. But before we do that, we just want to split up our ship, because we only want to be doing this to our main moving ship, and then split out our guns here and have them as additional colliders that we're just going to use this standard VDB approach. We can just take this part here. Let's just make a bit of room here. So select the rope, move this to the side, and we can adjust this later just to make a bit of space for our guns here. And then we can take this entire stream here, copy it over to the side, and then wait for it to finish calculating. And then we will call this collider ship underscore guns, and then here this is going to be collider ship and then guns underscore geo, and the same here. Oops, let's just put this capital guns, and this was our guns as well. All right, collider ship guns, set that up there, and now top here we're going to be splitting this. So let's drop down a split node, put that in here, and we want to split the section here And so what you can do is go into, just quickly save the scene because this also tends to crash sometimes. Let's just save as a new version just in case. So version 11, and here go to the selection tab, go to hit 9, and then go to the options here and choose path attribute. And so now we can select based on the path attribute. And so if there's geometry that does get added to or get removed, it's not going to affect our selection based off of just regular primitive numbers, which will change if this does change. And that's a fairly common issue when working in a regular pipeline, is models do get updated, and hopefully most of the time, not always, the naming stays the same. And so this stays consistent. You don't have to constantly worry about having the right stuff selected. So just go ahead, start selecting the stuff in here, maybe go to a later frame where the gun is popping out and then select it there. I've already done this. So I'm just going to paste the path in here, which is just based off different namings here that you can find under the path attribute here, just to select specific groups. And so if you're using the same model, feel free, go ahead and just copy this out of the scene here, because I will provide this, and then we'll call this split guns, and we're just going to invert the selection since the main ship is going to go here and then the other one is going to go to the other side. Now, one thing that we want to change here, or remove from the gun selection, is if we go here, we do have this outside cage, which is not getting animated. It's moving with the ship, and so we do want to have this added to the main ship. Otherwise, here we're going to have a hole, and once we do mesh this or convert this to a VDB, we do want this to get filled up and not have this empty space here. So let's just go here and split this as well, and then we'll take that and merge that back in here with our original ship. And so you can see here we're just adding that part in there, and now we can take this entire stream and hook this up here to our guns section. So let's just make a bit of space here, drag this to the top. So first we unpack, and this is going to take a bit of time, so we're going to cache that. Just unpack it, then a convert, because I think this is probably, no, it should be fine, but just for safety purpose, convert it to polygons. And then let's add a polyfill just to make sure all the holes are closed, if there are any. And we'll see if it tells us that there are some or if there are none. So just in a second. So as you've probably guessed, I completely forgot not to use the polyfill but the polycap. It's the same node, just with a different fill method, and the quadrilaterals, it's just going to kill your scene if it's you'd have to have something really small and simple that this doesn't crash your scene. And so one easy way, if you're on a Linux system, you can just open up a new terminal and then type X kill, hit enter, and then wherever you click next, it's going to kill that window. So we're just going to click on this and get rid of that. Now I've already opened up a new scene where we did our safety save before. So we just have to quickly rebuild that here. So let's grab our naming here. So we have our guns here, drop down another split to get back our outer area here, grab another path here, and then merge that back in with our mainstream here. That should be fine, and then hook this up here. And now what we did have is this unpack, the normals, just a safety convert in between. And now, this time, let's do this correct, save, and if we hit tab and type polycap, this should be set to single polygon, and that's what we want. So now Let's just drop this before the normal calculation. I mean, it's still, I think it's going to take a while, but this should help close any open holes and stuff that we do have with these pipes that I think that are open. Or maybe, let's see if it's telling us there's nothing to close. Some of them were not created. Doesn't matter. Should be fine. And then next we have our trail. So velocity computation. And then what we do want to do is, because if we check this here, if we go to our simulation here, and we're not going to be simming the same res as we're simming our pillars, because our pillars are do have some close-up shots, if you remember from the animatic, but the ship doesn't have shots that are very close up, so we can go with a lower resolution, and also we'll be covering a way much bigger domain, so this would probably not finish on this computer. And so I think what we will go here for is probably like 0.6 or something, which is still pretty good. And now if we go back to our guns here, quickly check the VDB from polygons, what we can see here is that our, so let's just convert this to polygons here. And maybe we do want to go a bit higher in resolution, so let's just multiply this times 0.5, so we at least have something a bit more decent. And let's just quickly convert this to polygons here, and now we can see that our surface here is not really getting picked up, and also like the nice detail we had in there is also not getting picked up. And so just to add a bit of thickness there for the SDF, we're just going to peak our geometry. So grab a peak, and the geometry that we want to apply this to, I'll just quickly do our selection here, is also another pre-made selection, but I'll show you in a second. So if we delete non-selected here, and of course we don't have the path attribute, since here in the unpack we do have to copy the path. And now just wait a second for this all to calculate. There we go. And now we have our blast here, and we just selected basically the parts that we want to peak, which are areas that are really thin and small. We just want to add a bit of thickness, so I just selected here the top surface parts here, which are the main ones, and then just to add a bit of additional stuff inside here, I just selected these small pipes and rows and stuff, and also the outer border edge stuff here, as well as the cage going down, just so we can add a bit of thickness to that. And so we'll take this exact same path, put it into the peak here, and let's hook this up, and then have a look at our peak. And let's try something very low, 0.25 or something. Let's see if this did change the overall thickness. Yes, it did. And now let's connect that to VDB from polygons and see if we do get a better representation. And now if we look through our convert, yes, we do have some thickness here. And this is, for the SDF representation, is perfect. Obviously, we do not want to peak the entire geometry, since we are using the geometry for some other collisions, and so we'll just leave that unchanged and just do this for the volume convert there. So this should be fine. We call this our guns collider, and we can go ahead and cache this in the background. Just send that off to deadline, and let's continue with the other part of the ship. So make a bit of space here, and this sim area center we will not need, since we're not alternating, we're not having multiple ships, or we want to place it in the center of that ship. So we're just going to do a placement of our tank here, and then this will always stay the same. So we can get rid of this part here. We don't need that. The only thing that we do have to make sure here in the flat tank is just to disconnect these two values, so the X and the Z, so it doesn't look for that. Now, here at the top, what we want to do, as I already said in the beginning, we want to grab the transform attribute, and then basically do our VDB calculation and then apply that transform to that VDB, and then you can do, as you'll see, it's almost real time. So let's create a null here just to reference to. And so what we will do here is drop down a time shift and then grab the very first, one of the very first early frames. So I don't know, I think it's just somewhere around 951, I guess. So let's just grab this frame here, freeze it, and then grab a part that we want to extract the transform from, and then apply that transform from that part to the entire ship. So let's just drop down another blast, and this is going to be our static X form, since this is the rest frame. And here I have another path set up, and we're just grabbing the front part here. And now to apply that to our ship to get it into the rest position, we'll just unpack our ship, drop down a wrangle, and now we're going to extract the transformation from the static one and apply this to this ship, and then we can get it into rest position. There we can create our VDB and stuff, and then from there we can apply the animated transform and put it back into the animation position. So let's call this to center, and this is fairly straightforward. So we want to grab the intrinsic attribute that we saw earlier here under, and then we want the packed full transform, and then apply this to our ship. So first let's create a matrix. This is going to be called our transform, and that is equals to, now we're going to grab our prim intrinsic. So prim intrinsic, and there we want it from the second input. The attribute that we want, or the intrinsic that we want, is the packed full transform, and we want that from the first primitive that it finds, which there is only one. And now to move the ship, we say v at p is equals to the inverse of that matrix. So transform, and we have a typo here. Yeah, and we multiply it, of course, multiply our position, and now we can see now it is sitting in the center. The invert of the transform, so the position that we have here, would be the center, and if we apply that to the same unpacked chip, then we have it in the center here. And now what we can do is we can grab this blast here, hold down Control Shift and Alt, drag it, and now the reference copy here, and we hook this up to our animated one, and now we call this our animated X form. Just move this to the side here, and if we drop down another wrangle, quickly grab this expression here, or just copy the entire thing, paste it in here, hook this up to our object that is sitting in the center, and hook this up here, and then we don't invert it. And now we should have our ship sitting with the animation. And now this is super quick, since it's just applying the transform and not having to recook the geometry every frame. And so we can do the same for our VDB and also apply the transform there, and then just have it move with it, and therefore we don't have to cache it. So so this one, let's just call this to anim. And just to make this clear here, let's just object merge, so we don't have all these crisscross lines going around. And we're probably going to copy this node setup here at some point and use that transform later as well. And what we want to do is we want to calculate our normals. So And the same stuff that we do here. So calculate the normals, and let's just add a rest position. So rest, drop that down there so we can use that reference to that later if we needed. And then transform back to the animation. And now we can go ahead and trail this. Let's just get rid of these nodes here. We don't need them. So, oh, went a bit off to the side here. So let's grab these nodes here, move them a bit over. I guess that should be fine like that. So back to the anim, then our trail. Move our color attribute, and also what we see here, we have this attribute anchor name, so let's remove that one as well. Anchor name, just to clean everything up, and then we can still leave the merge there, but we're going to be calculating our VDB differently. So actually we can keep the VDB calculation here. And so we'll just hook this up to our center object there. Let's see if it, this is going to take a while for it to calculate. Voxel size is fine for the ship, I guess. Don't need more resolution, that's okay. And then, now as you can see, we're not getting any holes here due to the part that we added back in. So this is all closed, which is good. And we don't need the collision velocity since we don't have a velocity attribute yet. We're going to be sampling that one later. And then here, VDB from polygons, we can now convert this to a regular volume. Oops, VDB convert. And the reason why we're doing this is because when we apply the transform, for some reason, I'm not sure, this worked at some point. But for some reason, if I do apply the transform to the VDB, you have to apply that to the intrinsics. So if you look here, you have the transform. It does some weird, strange behavior. And the only way that I figured that it worked at the moment, at least, is by converting it to a regular volume, applying the transform, and then converting it back. And so let's cache this here. So let's just drop down a ROP cacher, set this to our single frame. So render current frame, single frame. And then one thing that I'm noticing here is that we could add also disabling these parameters here. So let's just quickly do that. Allow editing of contents, type properties, and then go to the parameters. So just the sidetrack here, just to make it even longer, the section. So what did I want to do? We have the frame range, and if I think we turned off the valid frame range, so let's check here, valid frame range, and then disable when, and then we want to disable the start and end when this is set to the current frame. So that would be, I guess, probably 1, and this is not going to be single frame, where the attribute that we want to refer to, or the parameter, is T range, I think. And apply. Okay. I wonder which one this is. So if we check here, normal on, so off 0. So I guess if we set this to 0, let's hit apply, still on. Maybe we have to actually specify off. There we go. And now if we switch to render current frame, it just disables this, and then, yeah, perfect. Cool. Just a small sidetrack here, except match current definition. Oops. And now if we switch to current frame, it disables that. Nothing that would change the behavior, everything, it just makes it nicer to see that the frame range is disabled at the moment. And so let's call this our cache. And then we say collider ship main static. Oop, got a bit of typo here. Ship main static. And then let's just hit, so we set the single frame, save to disk, perfect. And now we have this cached. And so now we can apply our transformation here. So let's just drop down a wrangle, grab our animated position here, or we can just take this one, this object merge, put it here. And now what we want to get our transformation matrix. So let's go here, grab the same thing, plug it here. And what we want to do, we want to set the prim intrinsics attributes transform of this volume. And so set prim intrinsic of the input 0, so our volume. The value we want to change is the transform from the current point number. And then what we want to do for VDBs, this is different. We can just use the regular transform matrix, but for regular volumes, we have to convert this to a matrix 3. So matrix 3, and then our transform. And the operation that we want to do here is a multiply. Since that's the same what we're doing with our position as well, we're multiplying it. And then we have to also multiply our current position. So times equals our transform. And now, if everything went correct, we're getting a transform applied to our VDB. And now we can just scrub through this, and it doesn't have to recook the VDB every frame, and just saves us a bit of caching, also calculation, and the VDB is more consistent over time, although this will probably change once this gets sourced into our simulation. So let's just call this transform volume, and now we have to convert this back. So convert VDB, convert this back to our regular VDB. And we can merge this in. So if we just make a bit of room here with our cached version here. And what we want to cache here is the velocity attribute, since we don't have that here. So let's just grab our VDB from polygons node, let this cook for a second, hook this up to the trail, and then turn off the collision, add another surface attribute, take our point velocity, and then we will call this our collision vel. Collision vel, and the type, don't forget to change this to displacement acceleration, since if we do apply transforms to this later, this gets modified correctly. As with it, if we have this to color, for example, and you would scale this up, that wouldn't affect the vectors. But if we have this set to velocity attribute, basically that would also would change, because for example, if you just imagine you're just doing a regular rotation, you don't, and if you rotate, you do want your velocity vectors to rotate as well. But if you have a color, you do not want your color to change if you rotate your object. So just as a side note there, the voxel size is fine. So this is our collider ship. And we do not want to apply this to our geometry, so we can actually get rid of this, because our geometry, we don't want to cache that, since we're just using a transform here, and this perfectly works for what we needed. So let's get rid of the split here, hook up our geometry straight up there, and just cache our velocity here. And so we'll call this our ship main vel, and then we just merge that in with our SDF. And so if we just need, for example, the if we just need the SDF representation, we can just refer to that here, or we could like, for example, just add another null and just say that is just the SDF. If we don't need the velocity field for some reason, it's going to be much quicker because it doesn't have to read that from disk. So far, I think this basically wraps it up. The only thing that we do want to check here under our rope is make sure that the conversion is giving us a good representation here. Let's just get rid of this 0.5 multiplication just so this doesn't get too heavy. And let's just add a peak here, make this a bit bigger. Let's go with something small, 0.5. And just so we get a bit better effect there from the ropes in the water. Cool. That seems fine. And just because this is a bit heavy, and we do want to get rid of all unnecessary calculation times that we could cache out before, let's just drop down another ROP cacher. And we'll call this our cache collider ropes. Drop that in there. And that should be good to go there. Now, one thing that we do want to add or update is our collisions inside our flip sim. So let's just jump inside here. And so we have our collider ship. Since we don't need the pillars, it's not going to be in that range. And so we have here our collider ship geo, collider ship VDB, that is already connected because that was the pillar before. Then we have our rope. And what we want to add is our gun. So let's just drag that in there, connect that in here. And just for visual purpose, just change the order. Select this, and this is going to be our ship guns, and then we'll point this to our guns. And same for the VDP. All right, that's it for the flip sim. Just disable our simulation here. And just make sure for our meshing, ship geo, that's fine. For our whitewater sim, where is it here? What we'll do here is, since we only we only have one input here, we could either merge them together, but that's just going to add an unnecessary computation time outside. And so just going to get rid of this here, disable that, and then just add two static objects. And so we can grab them from our flip sim above here, jump in there, and then we have our ships and guns, and we don't really want to mess with the ropes, I guess. So just grab those two, copy, go down to our our whitewater simulation here, drop them in there. Maybe just merge them together like so, and invert. All right. Now we want to add this to our smoke simulation as well. So where do we have our smoke sim? That's the source. This is the smoke sim. And so under colliders, we have our collider. This is going to be the ship now. So collider ship, and then just add another one here. And this is collider ship underscore guns, and merge that in. So collider ship guns underscore VDB. All right. And I think for our mist, we don't have any colliders in there. Yeah, don't really need that. And that should be it for our collider setup. So in the next part, we're gonna start going over our simulation settings for the ship, since we do want to modify a bit the surface disturbance, add a bit more detail to that, maybe have it kick in a bit earlier so we do have a bit more disturbing before the ship breaks out, and also add another disturbance force onto the ship itself so that water that is lying on top of the ship isn't lying around completely flat, but does get a bit of movement and splashes around, things like that. So save our scene here. Go ahead and cache these. So the colliders, the velocity field here, the ropes. I think that's it for that part. Yeah. So save, and we'll continue in the next section.